Let's compute 4 cosine 70 degrees plus I sine 70 degrees to the third and write our result in rectangular form. A few things. This is currently written in polar form because I have r cosine theta plus I sine theta to a power. In this case, r equals 4, theta equals 70 degrees, and n equals 3. I can use DeMoivre's theorem to solve this. And DeMoivre's theorem says that z to the n is equal to r times the cosine theta plus I sine theta to a power, or r to the n times cosine n theta plus I sine n theta. And you can go back to the lesson to see a proof about this and why this is true. Applying the formula, then z to the third is equal to r to the third, or 4 to the third, times the cosine of 3 times theta, which is 70 degrees, plus I times the sine of 3 times 70 degrees. 4 to the third is 4 times 4 times 4, which is 64, times the cosine, 3 times 70 degrees is 210 degrees, plus I sine 3 times 70 degrees is 210 degrees. I was asked to write this in rectangular form though, and that means that I can use A equals R cosine theta and B equals R sine theta, or you can just distribute the 64. You get the same thing, because remember, if R cosine theta is A, when you distribute, you have R cosine theta, that's A, plus I times R sine theta, which is B. You get A plus BI when you distribute, but we need to evaluate the cosine of 210 degrees before we can distribute the 64. Using the unit circle, the cosine of 210 degrees is negative root 3 over 2. Plus I, the sine of 210 degrees is negative 1/2. Now I can distribute the 64. That means I have 64 over 1 times negative root 3 over 2 plus 64 over 1 times negative 1 over 2. I'm going to put the I at the back, and I'm going to reduce, dividing through by 2. I get that z to the third is equal to negative 32 root 3 minus 32i. There was a minus sign here, so a negative times a positive was a negative, and there was a minus sign here, which pulled in front. So that is z to the third in rectangular form. In order to compute negative 2 minus 2i to the fourth, I don't want to FOIL this and then FOIL again. I'm sure I could, but that's just not as fun. I don't really want to go, all right, negative 2 minus 2i times negative 2 minus 2i times negative 2 minus 2i times negative 2 minus 2i, and then FOIL, all that. No, thank you. I want to use DeMoivre's formula. So that's z to the n is equal to r to the n cosine n theta plus I sine n theta. But first I need r, and second I need theta. And we find theta by taking the inverse tangent of b over a, and we find r by taking the square root of a squared plus b squared. Looking at what we're given, remember complex numbers in rectangular form are written a plus bi, which means that a is negative 2 and b is also negative 2. R is then equal to the square root of negative 2 squared plus negative 2 squared. Negative 2 times negative 2 is 4. Negative 2 times negative 2 is 4. And so R equals the square root of 8, which is the same thing as 4 times 2, which I can then write as the square root of 4 times the square root of 2, or 2 root 2 in simplified form. Theta is then going to be equal to the inverse tangent of negative 2 over negative 2, or the inverse tangent of 1. The inverse tangent of 1 happens in multiple quadrants in the unit circle because it is pi periodic. So let's think about where our A and our B are. A is -2, B is -2. This means that we are in the third quadrant and our theta needs to be a third quadrant angle, which happens when you have -√2 over 2 over -√2 over 2, which is at 5 pi over 4. It's really important that you pay attention to where your A and your B are located so you get the right theta angle. And now we have everything we need. So z to the fourth is equal to r to the fourth times the cosine of 4 times theta, which is 5 pi over 4, plus I sine of 4 times 5 pi over 4. 2√2 to the fourth is the same thing as 2 to the fourth √2 to the fourth. And 5 pi over 4 times 4 over 1 reduces to just 5 pi. Two to the fourth is 2 times 2 times 2 times 2, which is 16. √2 to the fourth is √2 times √2, which is √4, or 2 times √2 times √2. So I'm going to write it up top here just so you see it. The square root of 2 times the square root of 2 is √4, or you could say the square root of 16 if you did all of it underneath one square root, which is 2 times 2, or 4. (16 times 4 is 64. I'm going to evaluate the cosine of 5 pi and the sine of 5 pi because I'm asked to put this in a rectangular form. Using the unit circle, the cosine of 5 pi is the same thing as the cosine of pi. It's a coterminal angle. 5 pi is 1 revolution, 2 revolutions, and then halfway around, which has the ordered pair -1, 0. The cosine of 5 pi is -1. The sine of 5 pi is 0. Z to the fourth is then 64 times -1, or -64.